Welcome to The Explainer. Today, we're diving into something that feels like it's been pulled straight out of a sci-fi movie, Xenobots, the world's very first living robots. Okay, so when I say the word robot, what pops into your head? Probably metal, right? Wires, blinking lights, that sort of thing. But what if a robot wasn't made of any of that stuff? What if it was built from life itself? All right, let's just get right to it. Meet the Xenobot. These weird little blobs are the world's first living, programmable machines. And yeah, they don't look like any robot you've ever seen, and that's because they're built from something completely, radically different. So what are these things really? We're about to get into what some are calling an entirely new form of life. Okay, so let's break it down. A xenobot is a tiny biological machine. And when I say tiny, I mean less than a millimeter wide. But here's the real kicker. It's built entirely from the skin cells of a frog embryo. You heard that right. No metal, no plastic, just living tissue. So they're made of frog cells. Cool. But what really blows your mind is what they can actually do. They can move all on their own. They can work together in swarms. If you damage them, they can heal themselves. And since they're made of living cells, when their job is done, they're completely biodegradable. This all sounds pretty wild, right? So how in the world do you build a robot out of frog cells? Well, this is where it gets really, really cool. It's this incredible mashup of artificial intelligence and biology. Let's walk through how it works, from computer simulation all the way to reality. The whole thing really boils down to three main steps. First, an AI dreams up the design. Then, scientists grab some living cells. And finally, they actually sculpt those cells into the AI's blueprint. So let's start at the beginning, the design. Before a single cell is even touched, a supercomputer runs these wild simulations. The AI is basically testing thousands upon thousands of different shapes to figure out which one is best for a specific job. You know, like just moving in a straight line. It's like evolution on fast forward, but inside a computer. Okay, step 2. The scientists go to the embryo of an African clawed frog. They take these stem cells from a specific spot that would normally just become skin. And this is a really important point. They're not genetically modifying anything. They're just taking what's already there and giving it a new purpose. And that brings us to the final step, where it all comes together. Using these incredibly tiny tools, the scientists literally sculpt and squish these living cells into the exact shape the AI came up with. And boom! What was just an idea in a computer is now a real, living xenobot in a petri dish. Okay, so we know how they're made, but this opens up a huge can of worms. What do we even call these things? Are they robots? Are they organisms? Or are they something we've just never seen before? Seriously, what exactly are these things? And this isn't just about picking a label. This question gets right to the very heart of how we define life and how we define machines. And get this. Even the scientists who created them can't agree on what to call them. One prefers biomachine, another says reconfigurable organism. Michael Levin calls it a proto-organism, while Josh Bongard is basically like, hey, maybe this just breaks all our old categories, which is a pretty mind-bending thought. So let's take a look at the robot argument. Douglas Blackston, one of the creators, comes at it from an engineering angle. He basically says, look, a robot is defined by its design, its ability to act on its own, and its ability to do a job we give it. What it's made of doesn't really matter. So if you design it to do work, it's a robot. Simple as that. And Sam Kriegman is on a similar page. He argues that it's the human intervention that's key. The moment we step in and shape these cells to do something new, they stop being just animal parts. They become, in his words, artifacts, artificial yet fully biological robots. So look, call them what you want, robots, organisms, whatever. One thing is for sure, this technology is a complete game changer. It represents a totally new way of thinking about engineering. Think about it. Traditional engineering uses passive stuff, right? Metal, plastic. You have to micromanage every single piece. This new bioengineering is totally different. It uses active parts, living cells. It's more about guided self-assembly. You're not forcing every little piece into place, you're just letting go of the reins and tapping into the natural abilities the cells already have. Here's a really great way to picture this. The old way of engineering, it's like building with Legos. The bricks are totally passive. They just sit there until you snap them together. The new way uses what the scientists are calling agential materials. These are living parts that have their own
well, their own agendas in a way. They already know how to stick together, how to communicate, and how to heal. They're active participants.
So what does this all mean? It means we can actually start to collaborate with life. We can program things not just by writing lines of code, but by shaping environments, by creating incentives, and then letting the cells do what they do best: build. Okay, so let's bring this back to the real world. What could this actually lead to? Well, the possibilities are just staggering. Imagine tiny biodegradable bots that can deliver medicine right to a cancer cell inside your body, or swarms of them cleaning up microplastics in the ocean, or even removing radioactive waste. We could even be talking about sculpting brand new tissues for regenerative medicine. But in the end, xenobots are more than just a cool new technology. They're a powerful new tool for discovery. They really force us to ask this huge question: what else do cells know how to do? We took these frog cells completely out of their natural home, and they showed us this hidden talent for building something totally new. It just makes you wonder, what other secrets are hiding in plain sight? And that's really the thought I want to leave you with. If something is designed like a machine, but it's built entirely from the building blocks of life, what in the world are we creating? It's a question that completely erases the line between biology and technology, and honestly, it's something we're going to be grappling with for a long, long time.